I think we'll need the lights for this. Wow, in a fraction of a second, I was able to turn on the lights. But what stores the energy so I can access the electricity so quickly? Well, there's two main types of energy storage, batteries and capacitors.
A battery is a simple system composed of a positively charged cathode and a negatively charged anode. In between is an electrolyte solution, separating the electrode charges. A battery works by converting chemical energy to electrical energy, so there are a couple chemical reactions occurring simultaneously. At the anode, the electrode reacts with the electrolyte in an oxidation reaction producing free electrons. Meanwhile, at the cathode, a chemical reduction reaction occurs, enabling the cathode to accept electrons. As electrons are drawn from the anode to the cathode, the electrolyte plays a role, separating the charges, forcing the electrons to flow through an external circuit. This movement of electrons causes electricity, producing electrical energy. A capacitor works similarly to batteries, storing energy with the movement of electrons. A capacitor contains two conductive, electrically neutral plates separated by dielectric or insulating material that stops the flow of current between plates. When a charge is applied to the capacitor, electrons on the top plate move to the bottom plate and accumulate on the bottom, since the dielectric layer does not allow the electrons to travel back up to the top plate. The top plate is now positively charged and the bottom is negatively charged. This leads to potential difference or a change in voltage due to an imbalance of charge between the two plates. This creates an electric field to store the charge from the top plate to the bottom plate, as indicated by the red lines. When the energy stored needs to be accessed, for example, turning on a light bulb, the electrons become attracted back to the top plate until both plates are neutral, releasing the electrostatic charge.
Now let's understand different metrics of performance measurement for batteries and capacitors.
Energy density is a measure of how much energy a battery or capacitor holds. Power density is a measure of how much power can be released from a device in an instant. Cycling stability measures the efficiency of charging and discharging a device over time. Comparing batteries with capacitors, batteries store a lot of energy, therefore having a higher energy density, but they can take hours to charge, indicating a lower power density. Conversely, capacitors have a low energy density, manifesting energy for only short periods of time. However, they charge much faster than batteries. In batteries, chemical reactions can cause them to degrade. However, in capacitors, there's only a charge transfer process occurring, so they can remain efficient for long periods of time.
So why is it important to know how batteries and capacitors work? Electricity is fundamental to our modern life and ever present in many fields, from batteries in zero-emission vehicles to capacitors in medical devices. Energy storage research is constantly evolving to make faster, sustainable, more efficient, wearable, and safer technologies. The field of energy is limitless, and that's the power of energy storage technology.